After understanding the total differential for its concept, we can apply it on economic situations like savings function. We know that the savings are dependent upon income as well as the interest rate. So, savings are dependent upon income as well as the interest rate. So, for that we can calculate the derivative, the total differential, to see the overall change in the savings due to income and interest rate. We know about the formula and the way we solve the total differentials. Here is the formula, and in this certain situation we will convert it into this form, which contains s as the dependent variable and y is the independent variable, as well as I is also a independent variable. The partial derivatives are there with respect to y and then with respect to I. When I calculate the partial derivative of saving function with respect to y, it is the MPS. We know what is MPS, marginal propensity to save. We know that whenever we take the derivative of any given function, we get the marginal function. So, this is no surprise, the marginal propensity to save will be found. And so, we begin with the calculations. We have rewritten the formula in this way. It's a more readable way as compared to this method that was there. So, now we have converted into a more readable way, where sy is the notation we have used and si instead of writing the whole derivative. So, we get we get rid of these two inside the function variables. We know that it is based on y and I. Just to make the things more readable, we are getting rid of these two values in the brackets. Here I was kept constant and the derivative was with respect to y, and here y was kept constant and derivative was with respect to I. So, we get this value. For this we have a numerical example, and we can solve this numerical example here. We have to find the total differential, and if this is the given function, we can easily do it. It's nothing difficult because I have the formula. Sy is something that I can find out simply by differentiating with respect to y, and I did it, and the answer was 1/2. Si can also be found with respect to I have this answer, and it is equal to 3. So, I have Sy and I have Si. Both of them, they can be substituted. I have done it here, and the remaining values, they are there. So, we get the total differential of the savings function, which is equal to this. Now, we can interpret this because the first part is actually showing the change in savings due to change in income. So, it is actually whatever change is brought in the income, we divide it by 2, that is make half of it, and we note it, and whatever change is brought in interest rate, we thrice it, we make it 3 times, and we note it, and then we add these two. Adding these two, I will get the overall change in the savings. So, you can see we have understood the dependence of S on Y and I, and we have observed that how change in S can be had by adding the effects of Y as well as I on the saving. So, in this way a simple economic application of the savings function by using the total differential is done here. Thank you.